Hello everyone, we have reached the second highest pointer of this puzzle GP set. This one's a Pentomino shading puzzle, and I've included 12 different Pentominos just above me for easy referencing. And we will be shading sets of 5 cells called Pentominos, so that each Pentomino is used exactly once eventually, and shapes can be rotated or reflected as needed. So for example, this is the I pentomino, but this is also a possible I pentomino rotated 90 degrees, or this is a possible W, but this is also possible. It is reflected along this axis. So different pentominos can never touch along their edges. So whenever you form a full pentomino, you can mark off everything that touches it orthogonally, but diagonal touching rules are a bit different. Two shapes must touch at every indicated point, but nowhere else. So this means that every dot has one of two potential markings around it. It will be forming a checkerboard. These two cells belong to different pentominos, and they touch only diagonally. But that also means that nowhere else can you be forming this shape. It isn't allowed to make pentominos touch diagonally without a marking on that point. So for example, whenever this occurs, you can determine what this cell is on the corner. I hope I managed to explain that properly. I've also added these dotted lines during the cuts for a bit more visual clarity, hopefully. So with that, let's begin. This lower right corner is a good place to start. I think of it either this or this cell is shaded, exactly one of them, but no matter what, there's a pentomino here that will want to get outside. So if this is shaded, these are unshaded, and it wants to keep going out, at least until here. And if the other shading is correct, it immediately becomes the U pentomino, like so. But in both cases, this cell and this cell have to be shaded. And now we can make use of the nearby pair of dots, because either this is true, or this is true. So there are a couple of shaded cells coming nearby. So if this is true, at first glance, this looks like it could be possible, but we have already said that either this or this cell, or this or this cell, also belongs to this pentomino that started to form near the lower right corner. So even if this is true, these cells cannot be shaded because they cannot connect. And if the other version is true, then these are a bit more obviously not connectable, because this is already 6 cells and even more here. So no matter which shaded cells are the correct ones, there is a block here, not a block, but they cannot connect to whatever is on the lower right corner. But now we have 6 cells and we need to fill 5 of them, so this obviously won't work, and the other version is correct, and we get our first pentomino. It is the U, and I unshaded this cell because if you shade this cell, there's a diagonal touching with another pentomino, but we don't have a dot in this spot, so this is unshaded. Now we can still make use of this pair of dots, because now one of the configuration is quickly broken. It's this, because this cell will need to get to 5 shaded cells. It will continue and make another U, the flipped version of it, but it's still the same pentomino. So we get this until here. Cannot form another U, neither can we touch this shaded cell diagonally. So we get to here. Now there's an observation that's always helpful later on the solve as well. If we take this cell Now these two are diagonally touching, but as there isn't a dot here, we cannot leave it that way, and we would need to take this cell as well, but this results in another U again. So the problem is taking this cell, we cannot, and these two cells will keep extending. Also, these dots started being useful when we shaded this cell, because the wrong version forces this. This is 4, this is additional 2, and they are already touching. They need to belong to the same shape, but it's too many shaded cells. We need exactly 5, so the other version is true. But these still cannot connect because this is 6. So they also don't touch diagonally because there isn't a dot there. And now this pentomino, whatever it might be, is actually pretty cramped because notice that it cannot take both these cells at the same time because it will force a connection with this and we get to 6 cells. So even if it takes this cell, there is a barrier here that prevents it from going up. So it could get to 2 cells, it could get this cell, it could get exactly one of these cells because they belong to a dotted points. So 1, 2, 3, one of these for 4, and it always has to exactly take this cell here. So we can erase these, but this is certain. I hope that was tractable enough. And this cell being shaded is actually pretty helpful because now it will make the violation more obvious. The wrong configuration is this, and now as there are no points here, we'll force both this, and we again get 6 cells shaded together. So this is no good. This has to be the correct version. And these 3 cells and this single cell are too far apart to be able to belong to the same pentomino. We again get to at least 6, but they're also not allowed to touch diagonally. So this is unshaded, this is unshaded. So we get an I pentomino, like so. This will need to continue, but if it goes directly above, then this shaded cell captures it in a sense and makes another U. As there isn't a point here, they cannot touch diagonally. So this stays away and becomes the V pentomino. This keeps extending. This cell we can unmark because it will forcibly connect too many things together. So this is no good. And this exact spot felt like a lucky break for me because there's one of the configurations that breaks in either case, which I thought was kind of interesting. If this was true, let's mark the unshaded as well. This lower pentomino is separate, so it won't connect to this. But now, if this part goes right, this is an L, but this here forces another L, so we have a repetition. But the other way forces a Z, but then this one forces another, so we also get a repetition. Not the easiest thing to see maybe, but we can determine the other way around has to be correct. And now this cannot be shaded because lots of issues there. So this shape is either an F or a P. So if it doesn't get this cell, it's a P. If it gets it, it's an F in either way. There's also a uniqueness metalogic again, but let's not do it. This shape is also 1, 2, maybe 3, maybe 4, maybe 5 cells. So it actually always gets this cell. And when you look at it, it's also an F or a P. So this shape isn't an F or a P. It has to take this cell anyway, but it cannot take this. And the wrong way around for these two, the F and P pair, forces them to be both the same shape. So if we get this cell, the other one also becomes a P pentomino. This stays away and becomes the F, and the other one becomes the P. And this is either a T or a Y. This cell is unshaded, this continues here. This also has to go on. And we have lots of partial shapes, and we need a final insight to be able to determine everything. So when we look at it, 5 of the shapes are already used, and when you count the unused but distinct shapes, there's one here, there's another here. We are counting them as separate because they are already diagonally touching, they are different. This is the third, this is the fourth, not counting this because these actually will have to connect, they can't even avoid each other. You can double check if you'd like. And then this is the fifth. So we have still a pair of dots that we haven't used at all. And as always, it has one of two configurations. But when you look at it, this version has this and this as brand new shapes as the last two shapes because we counted 5 completed and 5 uncompleted pentominos. We still need 2. And if this version is true, then the thing that starts from here and here are the 2 missing pentominos. But the other way around is also good because it connects here. So this isn't new, but this shape and this shape will be new for a total of 12 pentominos again. So what that means is that everything is, in a sense, accounted for. There isn't any freely floating pentominos around anywhere, so everything is connected to the dots eventually. And what that helps with is that seeing we haven't still put an X pentomino anywhere, and as the X cannot be rotated, well, can be rotated, but it's always the same shape, we can actually try to look for the X, but none of the existing incomplete pentominos could be an X. So for example, not this, not this, not this, not these connected, not these. So it has to be coming from the newly formed place with these pair of dots. So either one of these two is an X, but the upper one is more obviously impossible. This one could have been, but it's touching another uncompleted pentomino. So all in all, this has to be the correct version, and it has to be containing an X as a newly created pentomino, and it's obviously not the rightmost one. It cannot fit. And this definitely has to be the X, which will force everything really nicely, at least that's how I feel. So this is an N now. We have said that these are connected, so both of these two options results in an N, but we have used the N just now. It has to connect as an L. And here we are counting 1, 2, 3 maybe. This is the fourth cell, this is the fifth cell. It cannot be an L going all the way down there, so this isn't used. It cannot be a P because we have used that also. So we have this. We have used an N, just touching it. So this is the Y. This isn't the Y now. This is the T. And this is also not the Y. This is the Z. And the only thing remaining is the W pentomino. And it's already has its starts, so it can only be this way. And everything remaining is indeed empty. And we are through the puzzle. A pretty simple theme, just pairs of dots, but the idea actually came from a uniqueness metalogic involving the U shape, because it must always be found in a pair of neighboring dots for the solution to be unique. So I thought, let's make all of the clues into pairs if I can, and it worked eventually. It was kind of annoying to construct because when all you have to work with are pairs of dots, you can run out kind of quickly because every pair of dots introduces three new Pentomino shapes except the one containing the U. So with six pairs, you get 17 pentominos, well, pentomino segments, but you only have 12, so you know that there will need to be some pentominos that span across multiple pairs. And as I said, you cannot always have the pairs exactly where you want them to be, so it was kind of a journey to be able to make the puzzle, but I'm pretty happy with how it came about. Pretty logical, I thought, hopefully, let's say. So I hope this walkthrough was useful, and thanks for sticking around, and see you again soon.